Hello student, in today's class we are going to discuss geometry triangle formula. Now there is a disclaimer: the images, text and other material used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the same. So first is point, line and angle. So what is point? So zero dimension figure or a circle with zero radius is called point. Next one. What is line? So one dimension figure, line is a set of points having only length with no ends. We can represent line like that. Line segment. So a line with a fixed length is called line segment. So PQ is a line segment. Ray. What is ray? A line with unidirectional length is called ray. So we can say that from point B, A to B moving from one direction is called ray. Angle. So inclination between two sides or two sides is called angle. So ABC, theta is angle between AB and AC. So angle ABC equals to, we can say that, theta. Complementary angle. So if sum of two angles is 90 degree, then they are complementary to each other. So we can say that in given figure, alpha plus beta is equals to 90 degree. So they are complementary to each other. So complementary angle become alpha plus beta, which is equals to 90 degree. Supplementary angle. So if sum of two angle is 180 degree, then they are supplementary to each other. So we can say that in the figure, alpha plus beta equals to 180. So the supplementary angle become alpha plus beta, which is equals to 180 degree. Parallel lines. So two or more lines that never intersect is called parallel line. L parallel to M, we can say that. L parallel to M because the distance between these two lines always be constant. Next one. Transversal line. A line which touches two or more lines at a distinct point is called transversal line of the given lines. For example, AB and CD are parallel line and EF cut these lines at two different points. So this line is called a transversal line. So when two parallel lines cut by a transversal line, so their corresponding angles are equal. So we can say that 1 and 5 are equal, 4 and 8 are equals, 2 and 6 are equal, and 3 and 7 are equal. Alternate angles should be equal. So 3 and 5, 4 and 6. These are alternate angles. So in line and angle, if a diagram given like that and it is given that AB parallel through CD, then the value of alpha plus beta plus gamma will be always equals to 360 degree. Next one. According to this diagram, we can say that angle B will be always to equals to angle A plus angle C plus angle X. Next one. According to the diagram, we can say that sum of the angle of right hand side is always equals to the sum of the angle of left hand side. It means alpha plus theta is always equals to the alpha plus theta from left hand side and right hand side. Next one is, if these are parallel lines are given, so we can say that A ratio B ratio C is equals to P ratio Q ratio R, because these are parallel lines. So we can say that A upon A plus B plus C equals to P upon P plus Q plus R. Next one. If three parallel lines are given and two non-parallel lines cut these, two transversal lines cut these parallel lines, so AB by BC equals to DE upon EF equals to, we can say that, M upon N. So BE become AN plus BM upon M plus N. Triangle. A triangle is a three-sided polygon that consists of three edges and three vertices. So three sides, three vertices, three altitude and three angles in any triangle. So this is the diagram of a triangle in which we can see that three sides are three vertices, three altitude and three angles. So the ratio of the altitudes h1, h2 and h3 is always equals to 1 by a1 ratio 1 by b2, b ratio 1 by c. So h1 ratio h2 ratio h3 equals to 1 by a ratio 1 by b ratio 1 by c. So types of triangle, by side we can divide it. So by side if we see, so first one is equilateral triangle. So equilateral triangle has three equal sides, each angle is 60 degree. This is the diagram of equilateral triangle. Next one, biside based. So second one is isosceles triangle. So isosceles triangle has two equal sides and two equal angles. This is the diagram of isosceles triangle. Next one, on the basis of side. Next one is scalene triangle. A scalene triangle has three unequal side and three unequal angle. So this is the diagram of a scalene triangle. All sides are different in length and so all angles will be different. So we can say that angle A is not equals to angle B and angle B is not equals to angle C. And same way, side A is not equals to side B is not equals to side C. And the types of triangle based on angles. By angles, so we can say that first one is acute angle triangle. So this is the diagram of acute angle triangle whose all angle will be less than 90 degree. All three angle less than 90 degree. Next one, based on angles, second angle is right angle triangle. So this is the diagram of the right angle triangle. One angle of the triangle is right angle. So one angle is 90 degree. So we can say that in the diagram angle B is 90 and angle A plus C will be equals to 90 because the sum of the angle of a triangle is always 180. Angle based third triangle is obtuse angle triangle. So this is the diagram of obtuse angle triangle. One angle between 90 and 180. Let B is the largest angle. So AC, which is, we can let it as a B side. So this is the largest side. Now we can let it as a angle side of the side. So we can say that BC as a AC equals to B and AB equals to C, length of the sides. So let C is the smallest angle. So AB equals to C. So smallest side. Next one, inequality of triangle. Inequality of triangle, sum of any two sides is always greater than third side. For example, 4, 9 and 15, if make a triangle, this triangle is not possible because when we add 4 plus 9, it will become 13 and third one side is 15 centimeter, 15 unit we can let it. So the triangle cannot be possible. So because we know that the sum of any two sides will always be greater than third side. So 4 plus 9 is less than 15. So in a triangle ABC, difference of any two sides is always less than third side. Next one, acute angle triangle. So this is the acute angle triangle diagram. Since angle C is the largest, side C is the largest, so it will be happen when C square is always less than for A square plus B square on the basis of side. Right angle triangle, because we need to calculate the relation between three sides of the triangle. So if there is a triangle or right angle, so we know that if C is the largest angle and side C is the largest, so we know that C square equals to A square plus B square. So the relation between three sides of triangle when triangle is obtuse angle triangle. So this is the diagram of obtuse angle triangle. So the C is the largest angle and side C is the largest. So we can say that when triangle is obtuse, so C square equals to is always greater than to the sum of A square plus B square. Next. So see some triplets in right angle triangle. So this is the diagram of the right angle triangle. So we know that in right angle triangle B square equals to C square plus A square according to this diagram. So 3, 4, 5 satisfy this equation. 5, 12, 13 satisfy this equation. 7, 24, 25 satisfying this equation. 8, 15, 17 satisfy this equation. 9, 40, 41 satisfy this equation. 11, 60, 61 satisfy this equation. 12, 35, 37 satisfy. 20, 21, 29 satisfy this equation. 13, 84, 85 also satisfy this equation. 16, 63, 65 satisfy this equation. 20, 99, 101 satisfy this equation. 39, 80, 89 also satisfy this equation, which is B square equals to C square plus A square, or we can say that perpendicular square plus base square equals to hypotenuse square. So in this diagram B is the hypotenuse, so all these triplets satisfy this equation. Next one, types of angle. So first one is acute angle. So this is called acute angle. Acute angle, it means theta will be less than 90 degree. So theta will be between 0, more than 0 and less than 90. Second one is right angle. So in right angle defined as a one angle, the angle between two sides is 90 degree. So AB perpendicular to BC, so we can say that theta is exactly 90 degree. Now third one is obtuse angle. So this is the diagram of obtuse angle, and theta will be always more than 90 and less than 180. So theta between more than 90 and less than 180. Next one is straight or line angle. So this is the diagram of straight angle where theta is always 180 degree. Next one is reflex angle. So this is the diagram of reflex angle. So theta will be more than 180 and less than 270. So this is the reflex angle. Theta will be more than 180 and less than 360, not 270. Complete angle. So we can say that angle which is make 360 degrees is called complete angle. So theta will be 360 degree. Angle bisector. So a line divide an angle in exactly equal to two parts is called angle bisector. This line is called angle bisector. So we can see in this diagram. So BE is the angle bisector of ABC. BD is the angle bisector of ABC. 2 alpha plus 2 theta is all equals to 180 because this become a straight line. So alpha plus theta become 90. So EBD equals to 90, we can say that. So angle between internal angle bisector and external angle bisector of angle is 90 degree. So BD is the interior angle bisector of angle ABC and BE is the exterior angle bisector of angle ABC. Next one is vertically opposite angle in angle bisector. So this is the diagram of the vertically opposite angle. So opposite angles are equal to each other. Next one is altitude, height and perpendicular. So the perpendicular drawn from the vertex of the triangle to the opposite side. So this is the diagram of the altitude, or we can say that height, or we can say that the perpendicular length. So AD represent these things which are altitude, height, or we can say that perpendicular in a triangle. If triangle is obtuse angle triangle, so AD is again is the altitude, height or perpendicular. So we can draw like that in diagram. Now next one is median. Line drawn from a vertex to the opposite side which divide the opposite side into equal parts is called median. So AD is the median which bisect BC into two equal parts. It means BD equals to DC. So AD is the median of side BC. So BD equals to DC. Now perpendicular bisector. A line segment that is drawn from a vertex to the opposite side bisecting it at a right angle. So we can see into the diagram in this diagram the perpendicular bisectors. So O is the circumcenter where all three perpendicular bisector meet. Next one. Formula for area of triangle. So first we see the area of triangles formula. So the area of triangle is 1 by 2 into base into height. Next one is altitude and orthocenter relationship. So in any triangle ABC, AD is perpendicular to BC according to this diagram. So AB square plus OC square is always equals to OB square plus AC square. So O is any point on altitude. Next one. Sine rule of the triangles. So this is the diagram of the triangle in which AD is the altitude and A, B and C is the corresponding sides of the triangle. So the formula of the sine rule is A upon sine A is always equals to B upon sine B equals to C upon sine C equals to constant K. So A ratio B ratio C is equals to K sine A ratio K sine B ratio K sine C, we can say that. So A ratio B ratio C becomes sine A ratio sine B ratio sine C. So the area of triangle is equals to 1 by 2 into base into height. So area of triangle we can say that 1 by 2 into A into H. So 1 by 2 into A into H, we can say that C sine B. So sine B become H by C or H become C sine B. So sine C become H by B, which is equals to H, we can calculate B sine C. Same way C sine B equals to B sine C. So C upon sine C equals to B upon sine B. So we get the triangle's area which is equals to 1 by 2 into A into C sine B, and this is also equals to 1 by 2 A into B sine C, which is also equals to 1 by 2 B into C sine A. Next one. Side angle ratio of triangle. So this is the diagram in which angle B and angle A are 45 degree and angle C is 90 degree. So the relation between them is side ratio become 1 ratio root 2. Hypotenuse become root 2 and other two sides will be 1 1. Next one is when angles of the triangle are one angle is 60 degree, one angle is 30 degree and one angle is 90 degree, then the ratio become A ratio B ratio C is sine 30 ratio sine 60 ratio sine 90, we can say that. So the sides ratio become A ratio B ratio C is 1 ratio root 3 ratio 2. Next one is side angle ratio of triangle. So the angle one angle is 75 degree, one is 15 and one is 90 degree. So we get the ratio A ratio B ratio C, which is root 3 minus 1 ratio root 3 plus 1 ratio 2 root 2. Next one is if the triangle having the angle is 30 30 and 120 degree. So the ratio of sides A ratio B ratio C become 1 ratio root 3. Now see the cosine rule. So this is the triangle and their corresponding sides are given A, B and C. So cos B is equals to C square plus A square minus B square upon 2AC, which is also equals to B square equals to A square plus C square minus 2 into A into C into cos B. Next cosine rule. So cos B become same way C square plus A square minus B square upon 2AC, which is become B square also equals to A square plus C square minus 2AC into cos B. Next cosine rule. So cos C become A square plus B square minus C square upon 2AB, or we can say that C square equals to A square plus B A square plus B square minus 2AB into cos C. Next one is interior angle bisector theorem. So this is the diagram of the interior angle bisector of the triangle. AD is the angle bisector of angle A. So AB upon AC is always equals to BD upon DC if AD is the angle bisector, interior angle bisector. Same way length of the angle bisector. So when CD bisect the angle C, both angle are equal. So and bisect the AB in the ratio of M ratio N. So CD is the angle bisector of angle BCA. So X square is always equals to AB minus MN. A into B minus M into N. Next one is exterior angle bisector theorem. So this is the diagram of exterior angle bisector. So AB upon AC is always equals to DB upon DC. Next one is exterior angle bisector theorem. So this is the diagram. So area of triangle ADB upon area of triangle ADC become 1 by 2 into AD into BD into sine theta upon 1 by 2 into AD into DC into sine 180 minus theta. Is when we simplifying it, what we get? We get BD upon DC. Next one. Similarity of triangles. So two triangles are similar if they have the same ratio of corresponding sides or equal pair of corresponding angles. So size may be different but shape should be same in similarity. We know that. So this is the diagram of the similar triangle. So it could be possible that the length of the larger triangle is 4 unit and the smaller triangle is 2 unit, but they look like same. So we can say that they are similar. If two angle is same in a triangle, then third angle will be similar always. So we can say that these triangles are similar when it is given that two angles are 50 and 60. So third angle is automatically 70 because the sum of all the angles of a triangle is 180 degree. So these two triangles are similar to each other. Corresponding side. So sides opposite to corresponding angle is called corresponding sides. So in triangle ABC is similar to triangle DEF. So we can say that BC upon EF equals to AC upon DF equals to AB upon DE. Similar triangle and each corresponding length ratio. In similar triangle, ratio of each corresponding length is equal. So BC upon EF equals to AC upon DF equals to AB upon DE equals to H1 upon H2, or we can say that angle bisector 1 upon angle bisector 2 length, or median ratios median 1 upon median 2, or in radius R1 upon R2 equals to circumradius R1 upon R2, which is also equals to perimeter of triangle ABC and triangle DEF. So the ratio of the areas of similar triangle. So area of triangle ABC upon ratio of area of triangle DEF become 1 by 2 into BC into H1 upon 1 by 2 into EF into H2, which is equals to BC upon EF whole square, BC upon EF whole square, which is equals to AC upon DF whole square, which is also equals to AB upon DE whole square. Ratio of the square of the corresponding length. Now move to Thales theorem. Thales theorem: if a line DE is drawn parallel to one side of triangle BC, then it will divide other two sides in same ratio. Hence AD ratio DB is equals to AE ratio EC. So DE parallel to BC, we can see in this diagram. So triangle ADE is similar to triangle ABC. So AD upon AB equals to AE upon AC equals to DE upon BC. Next one. Convergence of Thales theorem. So if D and E, 2 points on AB and AC such that AD by BD is equals to AE by EC, then DE parallel to BC. Midpoint theorem. So the line segment in a triangle join the midpoint of two sides of triangle will be parallel to its third side, and it also half of its length of third side. Now we can see in this diagram. So D and E midpoint of, so AD parallel to DB and AE equals to EC. So DE parallel to BC. So triangle ADE is similar to triangle ABC. So we can say that DE equals to BC by 2. Which says that area of triangle ADE ratio of area of triangle ABC become 1:4. So area of triangle ADE and area of triangle DECB become 1:3. Next one. Proving similarity of triangle ABC and ADE. So this is the diagram in which ABC is a triangle and AED is also become a triangle. So A is common. So ABC, angle ABC equals to angle ADE equals to theta. It is given in the question. So we can say that the third angle will also be equal, because angle A is common in both the triangles and one angle theta is given. So a left angle will be always equal to each other. So this two triangle will be similar to each other. So triangle ABC is similar to triangle ADE. Property of triangle in any quadrilateral. So this is the diagram of a quadrilateral in which there are four triangles are formed. So we can say that an area of A1 multiplying by A2 is equals to A3 area of 3 multiplying by area 4. These are equal to each other. So we can also say that A1 by A3 is equals to A4 upon A2. And these A1, A2, A3 and A4 are representing the area of the triangles. Next one. Property of triangle in a trapezium. So this is a form of a trapezium. So the area of triangle AOD is equals to area of triangle BOC. In a trapezium, triangle formed on non-parallel side have equal area. So K we get as a under root A into B. Next one. Medial triangle. So this is the medial triangle in which PQR are the midpoint of the sides of AB, BC and AC. So PQR are the midpoints. So all these triangles are equal in area. Triangle APQ, triangle PBR, triangle PQR, triangle QRC having equal area. Next one. Medial triangle. So this is the diagram of the medial triangle. So PQR are the midpoints. So perimeter of triangle PQR is half of the perimeter of the triangle ABC. Next one. In medial triangle, this is the diagram. So PQR are the midpoints. So the area of triangle PQR become 1/4 of the area of triangle ABC, because these are having equal areas. Next one. Congruency of triangles. So two triangles are said to be congruent if all three corresponding sides are equal and all three corresponding angles are equal. Congruency of triangle, it means size and shape is same, not similar. So triangle ABC, we can say that the congruent to triangle DEF. So this is the formation of this congruent triangle ABC and DEF. So we can say that these two triangles are congruent to each other. Triangle ABC is congruent to triangle DEF. Now condition of congruency, side, 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 base. So the corresponding sides are equal. So we can say that these two triangles are congruent to each other. Side, angle, side. So two sides and angle between them is equal. So we can say that these triangles are congruent to each other. So this is the diagram of the congruent triangles. Next one. Angle, side, angle. So two angle and the included side between them is equal. So we can say that the triangle are congruent to each other. So this is the diagram of the congruent triangles. Right angle hypotenuse side. So this is the diagram of right angle, hypotenuse and sides base congruent triangle. So we can say that ABC, triangle ABC equals to triangle ABC because they are looking same. Sides are equal, hypotenuse are equal and angle is equal. AD is perpendicular to angle bisector of angle A. AD is the median So AD equals to angle bisector of BC. AD equals to all four center lie on AD, and this is the diagram of that AD. On line AD, these are the medians, angle bisectors, perpendicular bisector, and all four centers lies on this altitude of the triangle AD, and we can see in this diagram. Next one. Condition of congruency. Triangle PCA is congruent to triangle PCB. So PA equals to PB. P is any point. We can see in this diagram. Mass point geometry. So we can see in the diagram. In this diagram, we can say that M1 into L1 equals to M2 into L2. So we can also say that M1 upon M2 equals to L2 upon L1. Center of triangles. So first one is called incenter. Second is circumcenter. Third one is centroid. And fourth one is orthocenter. So first one, see, incenter. Incenter is the intersection point of all three internal angle bisector of triangle ABC. So this is the diagram of the all three internal angle bisectors which form a incenter of the triangle. So center of incircle is called incenter and its radius is called inradius. Incenter always lie inside the triangle. Incenter is equidistant from all three sides of the triangle. So triangle angle BIC equals to 90 plus angle A by 2. Same way angle AIC equals to 90 plus angle B by 2. And angle AIB equals to 90 plus angle C by 2. Next one. Incenter. So this is the diagram of the triangles incenter. So in triangle ABC, sum of the sides by 2 is called semiperimeter. Next one is incenter. This is the diagram of incenter. So circle in radius we need to calculate, so we can get it by the area of the triangle divided by the semiperimeter. We get the in radius of the triangle. Next one, in incenter. So this is the diagram of the incenter of the triangle. So in radius is area upon semiperimeter, we can say that. Now in center, relationship between in radius and altitude of a triangle. If altitude h1, h2, h3 are given, then 1 upon r equals to 1 upon h1 plus 1 upon h2 plus 1 upon h3. Ratio of segment in a triangle with an incenter. So this is the diagram where all three angle bisector meet. So I is called incenter. So we can say that AI upon ID equals to B plus C by A, or BI upon IE equals to C plus A upon by B. Same way CI upon IF equals to A plus B by C. Next one, in center. So this is the diagram by which we can say that PA equals to PB. So triangle AOP is congruent to triangle BOP. Distance between orthocenter and incenter in right angle triangle. So this is the diagram. So in radius we can calculate by the adding the length of the perpendicular plus base and subtracting hypotenuse minus h by 2, we get the in radius. Distance between orthocenter and incenter IO is root 2 r, small r, in radius. Next one. For equilateral triangle, in center is, this is called formation of the in center in equilateral triangle. We draw the angle bisector, and at point P all these three angle bisector meet, and this point is called in center. In equilateral triangle, this is the diagram. Height, or we can say that altitude AD is equals to under root 3 by 2a, or we can say that side. In equilateral triangle, this is the diagram. So in radius is area of the triangle upon semi perimeter, or we can say that when we use the formula root 3 by 4 multiplying by a square upon semi perimeter 3a by 2, so we get r equals to a upon 2 root 3, or we can say that r equals to h by 3. In equilateral triangle, this is the diagram. So circumradius is 2h by 3, or we can say that a upon root 3. A represents the side of the triangle. Next one. In equilateral triangle, in a triangle there is an incircle. So area of triangle ABC become, when the length of the tangent, which we can say that x, y, z, these are the parts, so we can say that it will become under root x plus y plus z into x into y into z. We get the area of triangle ABC. In equilateral triangle, this is the diagram of equilateral triangle. So in a radius become area of triangle upon semi perimeter, so we can say that under root x into y into z into x plus y plus z upon x plus y plus z. So when we simplifying, we get under root x into y into z upon x plus y plus z. We get the in radius. So in any quadrilateral, this is the diagram of a quadrilateral in which two circles are formed. So PQ, length of PQ is A plus B minus C plus D by 2, and A, B, C, D are the corresponding sides of the quadrilateral. Next. Ratio of radii of incircle in a triangle. So this is the diagram. So R1 upon R2 become 1 minus sine theta upon 1 plus sine theta. So the property of incircle and tangent in a triangle. So a circle is inscribed in a triangle ABC. Three tangent PQ, RS and TU are drawn of this circle. PQ parallel to AB, RS parallel to AC and TU parallel to BC. Three other circles are also drawn as shown in figure. So in the diagram we can see that. So the relation between R1, R2 and R3 in this diagram, we get R equals to under root R1 into R2 plus R2 into R3 plus R3 into R1. Next one. Calculation of in radius of a triangle. So this is the diagram. So BI equals to under root AB, or we can say that under root 2R. So R is the in radius of the triangle ABC. So we get R equals to BI upon root 2, or we can say that under root AB upon root 2. Next one. In any triangle, this is the diagram of a triangle. DE parallel to BC, I is in center, so DE equals to BD plus EC. Next one. circumcenter. So intersection of all three perpendicular bisector is called circumcenter of the triangle. So this is the diagram of the circumcenter of the triangle. So angle BOC equals to 2A, angle AOB equals to 2C, and angle AOC equals to 2 times of angle B. This is the diagram represent the angle. So circumradius of the circumcenter of the triangle, when we see in this diagram, so circumradius will become A upon 2 sine A, or we can say that area of the triangle equals to multiplying all three sides A into B into C upon 4 times of circumradius. Next one is acute angle triangle. Position of circumcenter in acute angle triangle. So in acute angle triangle, we can see in this diagram the circumcenter of the triangle inside. So OA equals to OB equals to OC equals to R. So O is the circumcenter. Right angle triangle, midpoint of hypotenuse. Position of circumcenter in right angle triangle, it will be midpoint on hypotenuse. So we can see in this diagram, angle C is the right angle of the triangle ABC. So we can say that R is hypotenuse by 2, or we can say that H by 2. In both diagram we can see that. Next one. In obtuse angle triangle, outside the triangle is the position of the circumcenter of the triangle. Now we can visualize it in the diagram. For any triangle, distance between incenter and circumcenter D is calculated by D equals to under root capital R square minus 2 times of capital R into small r. Next one is orthocenter. So orthocenter H is intersection of all three altitude of a triangle and may lie inside, upon, and outside of the triangle. So this is the diagram in which we can see the orthocenter. Next one of the orthocenter. So this is the diagram of the orthocenter. So we can say that area is 1 by 2 into base into height. So H1, which is also equals to 1 by 2 into B into H2, which is also equals to 1 by 2 into C into H3. And ABC are all the corresponding sides of the triangle. Next of the orthocenter. So this is the diagram. So A into H1 equals to B into H2 equals to C into H3 equals to, we can say that 2 times of the area of the triangle, which is constant. Next related to orthocenter. So this is the diagram. So relation between H1 ratio H2 ratio H3 is, we can get also equals to 1 by A ratio 1 by B ratio 1 by C, where A, B and C are the corresponding sides of the triangle. Next one is, we can see the diagram. So in this diagram we can say that angle BAH, which is equals to angle OAC. We can analyze by the diagram. Next one. By the diagram, we can say that AH into HD equals to BH into HE equals to CH into HF. So the triangle AHE similar to triangle BHD. So AH upon BH equals to HE upon HD. So we can also say that AH into HD equals to BH into HE. Next one is the position of orthocenter in right angle triangle on 90-degree vertex. So this is the diagram. So OB, distance between orthocenter and circumcenter R. So we can say that R equals to H by 2. Position of orthocenter in obtuse angle triangle. Outside the triangle, orthocenter. So we can see that the diagram, H is the orthocenter of the triangle ABC. Now see the Euler theorem. What is Euler line? So in any triangle, H, G, O are always in a straight line. See the diagram. So H, G and O all in a straight line, and this line called Euler line. So Hg upon Go equals to 2:1. So triangle AHG is similar to triangle EOG. So Hg upon Go equals to 2:1, which is equals to AH upon OE. Next one. Relationship between interior and exterior angle of cyclic quadrilateral. So interior angle of a cyclic quadrilateral is equal to the opposite exterior angle. So we can see in this diagram. Next one is, now according to diagram we can say that n circle of equal radii r are made on side BC. R will become area of triangle ABC upon S, which is called semiperimeter, plus n minus 1 into H. S represent the semiperimeter. Next one. Centroid. So this is the centroid of the triangle, where all medians are meet is called centroid. We draw the medians of the triangle, and at that point where all medians are meet is called centroid. Centroid is the intersection point of all three medians of the triangle. So median divide the triangle into two equal areas. So the centroid always lies inside the triangle. Apollonius theorem. To find the length of the median, by this diagram we can say that 3 times of AB square plus BC square plus CA square equals to 4 times of AD square plus BE square plus DF square. So theorem says that AB plus BC plus CA upon AD plus BE plus CF is always greater than 1 and less than 4/3. Next one. In Apollonius theorem, by this diagram we can say that AO ratio OG ratio GD will become 3:1:2. 3:1:2. So the area of triangle GEF is equals to 1/12 of the area of triangle ABC. Next one is, by this diagram we can say that triangle of area of triangle GEF and ratio of area of triangle ABC is 1/12. So area of triangle DEF and area of triangle ABC become 3/12, which is equals to 1/4. If two medians of a triangle intersect each other at 90 degree, we can see in this diagram. So we can say that AB square plus AC square equals to 5 times of BC square. Next, property of the median in a right angle triangle. So by this diagram we can say that AO equals to OC equals to OB equals to R. So OB is equals to hypotenuse median, or we can say that the shortest median. So circumradius R become h/2. Property of median in a right angle triangle. So we can say that if DE are two points on BC and AC, according to this diagram, we can say that AD square plus BE square equals to DE square plus AB square. Next one. Thank you.